Hello and welcome to this demonstration video for the Abstract Data ADE-30 Wave Boss eurorack module. The Wave Boss is a utility module with 4 distinct stages. Each stage can be used in isolation or they can be connected together depending on your needs. The 4 stages are represented here by 4 rows of 3 jacks each, and also stages 1 to 3 have 2 knobs each, 1, 2 and 3. Stage 1 is a gain, attenuation and inversion stage. There is a signal input jack here, a signal output jack here and a CV input jack here. This knob here controls the internal CV and the amount of inversion, attenuation or gain, and this knob here controls the amount of external CV input from the CV input jack here. This stage can be used as a VCA, it can be used to boost or attenuate CV signals or audio signals, and of course it can be used to invert. Stage 2 is a bias stage, meaning it will add or subtract a constant voltage to the signal coming in, or if there's no signal coming in, it will simply output a voltage. Again, there is an input jack here, an output jack here, and a control voltage input jack here. The internal CV knob here controls the amount of bias, and the external CV knob here controls the amount of CV input from the middle jack there. You can see the 2 LEDs show the positive or negative amount of the bias or CV output. Stage 3 is a bipolar clip stage. There's a signal input and a signal output and a control voltage input, just like the other 3 stages. This internal CV knob here will control the amount of bipolar clipping to the signal going in, and this knob here will control the amount of CV control voltage input coming from this jack here. This stage is really useful for distortion and wave shaping. Finally, stage 4 is a half-wave rectification stage with 1 signal input and 2 outputs for the half-wave rectification positive and negative side of the waveform. There are no knobs for this stage. So let's take a look at some patching examples. Okay, in this example I'm using stage 1 as a VCA. On my yellow cable is a simple pulse wave going into the signal input. On the red cable I have the output of an envelope going to the CV input, and on the green cable I have the output going to my sound card. So we can't hear anything at the moment because the internal CV knob is at the 12 o'clock position, meaning that the signal has been attenuated to 0 volts. If I push it clockwise or anti-clockwise, you'll hear the pulse waveform. So that's inverting and attenuating the signal. Now my external CV knob is already high, so all I have to do is trigger my envelope, and the CV is applying gain to the signal. Apply a bit more or a bit less. So that's using stage 1 as a VCA. Okay, in this example I have an LFO coming from my maths here going to the signal input of stage 1, and then the output I've got going to the pitch of an oscillator, which you can hear warbling away. So what I'm going to show here is how we can use the internal CV knob to basically boost, there, attenuate through 0 volts, and then invert the signal with various amounts of gain. Okay, in this example I'm using stage 2 to apply a voltage bias to an incoming LFO. The LFO is coming from the maths on the red cable to the signal input, and the signal output of stage 2 is going to the frequency input of my oscillator. You can see the LED is here showing a fairly stable AC voltage. So if I turn up the internal CV knob, you can see it just goes into the positive side of the waveform there because of the bias control voltage, and down to the negative. Okay, here we're using stage 2, and this is just to show that we can use it as a constant control voltage output with nothing connected to the input, nothing connected to the CV input. We can just simply use the internal CV knob here to control anything we like. In this case, it's the pitch of my oscillator. So that just outputs a constant control voltage. Okay, in this example I'm using stage 3 to apply some bipolar clipping to an LFO that I've got the output going to the frequency of my oscillator. So the input here is coming from the LFO and the output here is going to the oscillator frequency. We can see the LFO swinging between positive and negative voltages here. So if I apply clipping, you'll begin to hear the clipping, and you should be able to hear the sine wave of the LFO being flattened off at the top and bottom edges the more we apply. So it starts sounding a bit more like a square waveform until we can clip all the way down to just a flat CV output. Now with audio rates, I'll just put my LFO up to audio rates. You can hear the wave shaping effect. Onto stage 4, and in this patch I'm using an LFO going into the signal input of stage 4, and here I've got one of the half-wave rectification outputs going to the pitch input of my oscillator. What you should be able to hear is only the positive half of the LFO waveform being output through this output here. So what's happening is you're getting the positive half of the sine wave and then it's flattening off, and you can hear the pitch just flattening off. If I slow the LFO down, you can hear the pitch just flattening out at the bottom. Let's have a listen to a slightly more musical patch for this. Okay, in this example I'm using stage 4, which is the half-wave rectification stage. For an interesting application, what I've done is I've built an envelope follower. The drum loop you can hear is going through the yellow cable into the half-wave rectification circuit. The two outputs are being summed and sent through a filter, with the low-pass output going to the frequency of an oscillator. And this circuit essentially makes an envelope follower. If I turn up the output on the oscillator, you should be able to hear. So that's it for this video. That's the ADE-30 Wave Boss from Abstract Data. The links are in the description for this YouTube video.